Hello everyone, welcome to Learn Overflow. In this video, we will discuss about this LeetCode problem that is the search suggest system. This is a medium level LeetCode problem. Okay, let's look into what the problem is saying to us. Like you were given an array of string products and a string search word. Yes, so that's what they're given to us, a products and a string search word. Okay. Design a system that suggests at most three product names from products after each character of the search word is typed. Okay, suggest products should have common prefix with search word. If there are more than three products with a common prefix, return lexicographically minimum products. Okay. If there are more than three, then return lexicographically minimum three products. Okay. Return a list of list. Okay. That should be the final return type. Return a list of list of the suggested product after each character of search word is typed. Okay, so with this question we can like literally, like if you read this line, like suggested product should have a common prefix with search word, and it should be like after each character is typed, it we are clear that we need to traverse this search word and like think of this like without even looking at the examples and all. By the question itself you can think that we need to take each of the prefix we can have in the search word, like each of the starting prefixes we can have, and then based on that, if there has like the in the products array, if there are strings with that prefix, or the strings starting with that prefix, then we should add them to our list. That's kind of stuff that is trying to say over here. Let's try like see an example and try to understand this better. Okay, so in the example, we are given like a products are there, and it's like a mobile mouse, money pot, monitor, and mouse pad. Okay, so these are the stuff given to us in that, and next is given the search word is mount. Okay, so according to this output, it's like when first aim is typed. So first aim is typed, then mobile, money pot, and monitor is being printed to us. That means this one mobile moneypod monitor. Okay, monitor, so that means this is more or less like mm, it's in lexicographical order, right? Like if there are more than three products with common prefix, return the three lexicographically minimum products. So that's what they return does. So maybe the products is not lexicographically sorted, like this array is not lexicographically sorted. We need to make sure about that. All right, so when this aim is typed, this is the output we get. When like the next one is mo, right? That time this is the output is typed, and then from MOU, you will see this kind of output being given to us, because like MOU is uh, only with two like strings we have, right? Then all these three are like MOU, MOUS, MOUSE. So these are the stuff we get here, and that's the final output. This is the suggestions we have, and that's what we need to return to us. Yes, that's what is being explained over here. All right. Let's look into the other example. It should be more or less clear that what the question is trying to say out here right now. Let's look at the other example to see if there is any hidden string, like hidden cases or something like that. All right. So in this case, even if we look at the example number 2, then we can say if it has Havana, and the word search word is also Havana. So it's like H is first searched, and then HA, HAV, HFEA. So we can see like it's like the more or less like we need to find out the maximum like all the word or the all the characters in the string word is typed one by one, and we need to add a list with respect to that whatever we have here. Okay, so whenever we see like we need to do a kind of a prefix or like the prefix of the words are needed. So it's always a best idea to go with try. And maybe depending on the question, you should look ahead into this. But the best way is always to go with try. But we can have a simple solution for this. Okay, simplest solution that we can have for this is using like priority queues, because in that you don't need to sort the array, because this input that the input we are getting over here, it needs to be sorted. But with using priority queue, we can ignore, like we can skip that part of sorting this. Rather we can simply have a product out here. So let's so this can I will go ahead with the two solutions. This particular solution, I don't think this will be the best case solution. It will have more time complexity. So first let's understand this priority queue solution, where we won't be using any kind of sorting on all, and also not a try. In the next solution we'll look into the a more depth try solution, a try based solution for that. So I think this question is clear out here, that what we are trying to do and what exactly we need from here, right? So before we go with the solution, let's look into the constraint. The constraint says that the product array, this product array can have a length of maximum 1,000 and minimum it's 1. So it's sure that the product array is not 0. So we don't need for that check case. And this product of I length, like each of the string in this product array can have a maximum length of 3,000. So that's also an case with us. And the next thing is it says that the sum of products of I dot length, like each of the words in the product array, their length of each of the words, their sum is less than 2 to the power 2 to the power like 2 into 10 to the power 4. All right. So all this thing in the products are unique, so there isn't any repeated words. Like the products of I consist of lowercase. Okay, there are only 26 characters, like maximum 26 character can be there. So that's a hint towards our try best solution. And also it says that the one less than equal to search word dot length is less than equal to 1,000. Okay, so this search word can have a maximum of 1,000 elements. Okay, like 1,000 characters. It's more or less like you can see that the products of I can have the more length. That's what is you can know here. And search word also had a lowercase English alphabet. So okay, that's all we have over here. The solution is pretty simple. We'll traverse with each of the characters of this search word. Okay, so each of the character, rather you can say a substring, or rather each of the character being added as a prefix. So that will be the more idea over here. So we'll just search with each of the characters being added one by one, and then search in our product array if it starts with our with a particular word or not, like the particular prefix or not. If it starts, then we'll add to our like the sub array. No, this sub list. Okay, this inner list, and then add to our final answer list. So that will be the more or less the idea behind this. So let's go ahead and start with this. Okay. In the first thing, we just got here two things. The two things being this one is our answer that we are going over here. So this will be the final return type of here. Okay. So anyways, after after doing all the calculations, so we will do our return answer over here. Okay. So that will be the last statement. So everything we wanna do will be in between this. Okay. And there we got a priority queue. Now you need to understand something about the priority queue. The priority queue with a string, and we got it a length of 3. So why length of 3? If you remember exactly, then this was the being said to us. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Okay. So so we need maximum 3 products. So there's no need to store all the products and then do something with that. Okay. So we can have a maximum 3 products and do with that. So how we are storing this like the priority queue, the main ideas behind this is like storing with like with a comparator. We are adding a comparator over here. This is like s1 dot compared to s2. So when you do something like a string dot compared to another string, that's basically compares in a lexicographically manner. So is compared to is an function of the string class. So that's what the idea behind this. Now, this is what we can do right here. Okay, so this is the part that will compare each of a string based on their compared to methods, like the how compared to method compares to string. Okay, so that's the idea behind this. Now let's start. Like let's go ahead with taking each of the characters from our search word, and then we'll just search for it. Okay. We just got a string called prefix, and this is a null string, like we don't have anything within it. And then we just traversing through each of the character of this search word. Okay, we have this search word given to us. So and we just transform this to a character array, and then we are just traversing with each of the characters. And then the first thing we're doing is like we are adding this character to our prefix, so that we can add one by one and increase the prefix simultaneously. Now within that, we have an stux to do is that, like for each of the string p within given in our products. So this is the products array we have, and for each of the string p in products, we are just checking if this string starts with a prefix or not. If this starts with a prefix, then we do pq.offer. So pq is our priority queue we have here. So we just pq.offer is adding to the pq, the priority queue. So this priority queue will have a maximum 3 products, and thus it will go on adding, and all the lexicographically smaller elements, or the thing is lexicography minimum products will be stored in our priority queue. Okay, so that's the idea behind this. So it that will have a maximum 3 products. Okay, so we got our thing stored over here. Okay, so that's like each of the character we got our string. Now the main task we have here is, the main thing we need to do is like the next thing rather is like have a temporary list over here. Okay, list of strings that will be our this inner string. Okay, like inner string being added to our final answer. So have a temporary list of string, and then like take out all the elements, all the 3 elements, or less than equal to 3 elements that are there within our priority queue, and take them out and add them to our temporary list, build a list, and then add them to our final answer list. Okay, so let's go ahead with that. So what exactly we try to do here is like we got a temporary list for us, and then the next thing is like we know that there will be 3 elements, so we just traverse like 0 to 3, like we have a loop for 3 times, doing it 3 times, and then we just check if like pq.peak is not null. Why we have a check over here? The check being it can have less than 3 products, like an example over here. Like it may have in the third case, while the loop is still running, on the third case we should find that the peak is like null. So like we're just noting down that if the peak is not null, then pull the elements and add this to our temporary array list. Okay, so like that's the basic idea behind this. And then the next thing we need to do is like this is not necessarily needed because we have 3 elements, but it's better to just clear off the priority queue. No, it's like the main idea being, in the first case, say we are going ahead with like aim only. So in the first thing, if you just notice over here, so here we just went ahead with the aim only. Then for that we have these 3 elements, right? So if we don't clear this priority queue, then after this second element, it won't create a problem in this particular example. But after this second element, when you find this only 2 should be added there, then using the lexicographical order, then mouse and mousepad won't be there. It will be like this 3 will be there itself. So we need to clear our PQ, that make sure that nothing is within our PQ before checking for the next character or adding the next character over here. Okay. Now, so that means we should just clear this PQ after we got this, and then we should like list, no, not list, our answer dot add the stem. Okay, so this is what we got here over here, and then we added our answer for each of the character we got here, and then we just returned our string. So let's run it and check. You can see like gives us an desired answer, and that's an accepted answer as well. So let's run further. Try to submit this. Yeah. So exactly as I said, like it's not the best case answer. So thankfully, it didn't give us an time limit exception, but but it did take us like 49 millisecond time. So this is an answer. There is another answer. So I'll make a different video for that. Soon the video will also be uploaded in the channel, like an hour or so later after this video gets uploaded. So that answer will be based on a trie-based solution. So make sure that check that out as well. Okay. So that will be a more of a trie-based solution for this type of answer. So thank you all for watching this video. Hope to see you soon in my next video as well with a trie-based solution also. Thank you all.